So the last question, D, is really just the meanest part of this entire question. And it's really not that bad. It's just kind of a pain. So we're going to go through it and realize this one is worth 3 points. It is worth the most on this whole assignment. So let's go through it. The height of the tree in meters can also be modeled by a function g, given that by g of x equals 100x over 1 plus x, where x is the diameter of the base of the tree in meters. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. According to this model, what is the rate of the change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall? My goodness, at first I'm like, what the heck? But I am seeing something like this. You can kind of get the hang of how these questions are being asked. So this is saying that it's increasing at a rate of 0.03. I'm getting this feeling of a related rates problem. So the diameter, notice it's the diameter, which was said to be x, right? X is the diameter. So the rate of change of the diameter there is 0.03. So we know we're going to be dealing with related rates. So x prime or dx dt, however you want to think about it, I'll write both. Dx dt, which is x prime, is 0.03. And it probably doesn't hurt to do dx dt on a free response question so they see that you know what you're talking about. But worst case, just put the x prime. And so what else are they giving us here? Well, they're also giving us that g of, when the tree is 50 meters tall, the diameter of the base of the tree is increasing at that rate. So they're not giving us the time. They're just telling us that g of t is, or g of x actually, is 50 meters tall. So we can come up with what x is given that. So let's first, before we figure that out, let's just go ahead and start with figuring out what our derivative would be. So we want to figure out what is the rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall. So we want to really find g prime of x. And we want to find it, though, it's kind of weird. It's finding it in respect to time. This function g of x is not in respect to time. It's in respect to x. So that's what's going to make this a kind of a little funky related rates problem. So we have that g of x equals 100x over 1 plus x. But we want to find the derivative in respect to time of g of x. So the derivative in respect to time of g of x, let's think about that. That's going to be g prime of x times the derivative of the inside, dx dt. Now remember, we normally don't do the derivative of the inside, but since it's in respect to time, if it was in respect to x, let me just show you that real quick. I'll erase this right now. Derivative in respect to x, this is what would happen. You normally don't put that. You just do g prime of x, right? Because if you put dx, that just goes away, and there's no purpose to doing that. But here we're doing it in respect to time. So derivative in respect to time was g prime of x times the derivative of the inside in respect to time actually will have a derivative. So that's what we're going to see right now. So, well, what is g prime of x? Let's just start with the derivative of this. G prime of x, well, that would be 100. We got to do quotient rule. 100 times 1 plus x minus 100x, because the derivative of the bottom is just 1, over 1 plus x squared. So that's just the good old quotient rule. You guys can go back to the quotient rule, look that up, figure that one out. And then we're multiplying this by dx dt. Well, what is dx dt, or x prime? Well, it's 0.03. We're going to substitute that in. Our problem is we don't know what x is. We do know that g of x, though, is 50 at this point. So what I can do is I can substitute in, g of x is 50, so I'm going to substitute that in. 50 equals 100x over 1 plus x. And then we got to solve this, so I'll multiply the 1 plus x to the other side. So I'll get 50 plus 50x, little cross multiplication here. And then subtract the 50x, so 50 equals 50x, divide the 50, and you get x is 1. So what we have is that x is 1. We have x prime is 0.03. Let's just substitute this in. So we'll have 100 times 1 plus 1 minus 100 times 1 over 1 plus 1 squared times 0.03. Remember, we don't have a calculator on this portion. 100 times 2 minus 100 over 2 squared times 0.03. And then that's going to be 200 minus 100 is 100 over 4 times 0.03. Well, 100 times 0.03 is just 3 over 4. So taking a look at this problem, I believe that's the answer. So it's saying, according to this model, what is the rate of change of the height of the tree with respect to time? That's what we did. Rate of change of the height of the tree. So the height of the tree is g of x. Rate of change in respect to time is d dt in meters per year at the time when the tree was 50 meters tall. And we use that whole time in the tree, time in the tree is 50 meters tall to figure out what our diameter was. And then we're also given that rate 0.03, plug it all in, and you get 3 over 4 as your answer. And that's it for that problem.